Hello everyone, I'm here to present our research on user-centered design for knowledge imbalance analysis, a case study of PROUD. I'm Nadia from Universitas Indonesia, one of the 6 people who worked on this research. I worked with Dr. Faris Durari, Dr. Pancha, Dr. Bernard, Dr. Simon Rasniewski, and Refo Ilmia. First and foremost, I want to explain a little bit about Wikidata. Now, Wikidata is a free knowledge base initiated by the Wikimedia Foundation. Free being that anyone in the world can access it and also contribute. In storing information, it follows the RDF data model, which are basically subject, predicate, object triples, which in the context of Wikidata, they are in the form of items with predicates. Now, as an example here, we can see the National Monument of Indonesia, or more commonly known as Monas, as an item in Wikidata. Now, every item in Wikidata has its own unique ID, as we can see here for Monas. In this case, Monas has information about its country property with the value of Indonesia. So here, Monas acts as the subject, country as the predicate, and Indonesia as the object. So there we have an example of a subject, predicate, object triple. Now, the Wikimedia Foundation issued a white paper, which one of the discussion is the existence of knowledge imbalance in Wikimedia projects, and one of them is Wikidata. To explain a little bit about knowledge imbalance, an example here we can see Monas and the Statue of Liberty. These two items are similar in the sense that they are both landmarks of their respective areas. And here we can see that the Statue of Liberty has 94 statements, while Monas only has 15 statements. And the interesting thing here is that the properties that are missing from Monas, though exist in the Statue of Liberty, are properties about its creator, architect, height, and area, which definitely exists in real life, though simply not yet stored in Wikidata. And from this small example, we can see that an imbalance really does exist. And this is just a small example which can happen in a much larger scale in Wikidata. Now, where does PROUD come into all of this? So, PROUD is a tool created to visualize those imbalances in Wikidata. Imbalances here being the differing level of property completeness of the items in Wikidata. For an example here, if we want to look into the imbalance in inventors in Wikidata, then we can choose to visualize humans with the occupation of inventors. Then as an example here, maybe we choose 5 properties that are relevant to our search. Then PROUD will visualize how all these humans with occupation inventors in Wikidata owns those 5 properties. Here we can see that one inventor has all 5, while others not so much. And from that, we can see that the imbalance that exists between all of these inventors based on the level of property completeness. Now, PROUD was previously developed in a technology-driven manner, meaning that it did not look into the user experience aspect of the application. And the creators who are also involved in this research wants to improve PROUD for users. And to do so, in this research, we selected the user-centered design or UCD approach to reach that goal. To simplify, this research contributes in discovering the adaptation and implementation of the user-centered design approach in the knowledge graph setting to improve PROUD, which is a knowledge and imbalance analysis tool. So how can we make PROUD better? To improve PROUD for users, the creators not only want to make PROUD more user-friendly, but also introducing it to potential Wikidata users, which are basically people who might benefit from the information which are presented by PROUD. Now, a little bit about UCD. It is an approach which comprises of 4 main basic activities. Firstly, we go to understand the context of use of the product, and then to specify the user requirements, and then with those requirements, we can design the alternative solutions. Then those solutions are evaluated against the requirements we've established previously. So UCD, as its name suggests, centers the users in the development process, which means that the user is involved and kept in mind throughout the entire process. And here we can see that UCD is iterative in nature, though in this research we only did 1 full iteration to see the results of UCD to an application such as PROUD. And as previously mentioned, we begin by understanding the context of use of the product, which in this case is PROUD. So in this segment of the research, we held meetings with the Wikimedia community who resides in Jakarta, We also participated in a forum in Wikidata to propose the idea of Proud, and we also held discussions amongst the creators of Proud. And from those discussions, we formulated that there are two main challenges in developing Proud. One, that it surrounds an abstract concept that is the Wikidata knowledge graph, and an even more abstract concept, which is the imbalance analysis of said knowledge graph. Second is the fact that though Proud has existed, it did not yet have an existing user base. Hence, we identified the users we ought to target, which are the Wikimedia community and potential Wikidata users, which are basically data professionals, data journalists, and AI researchers. And now that we've understood Proud, we can start the requirement gathering process. As Proud has existed previously, we can gather some generic requirements by doing a heuristic evaluation using the 10 usability heuristics on Proud version 1, while also to acknowledge our target users, we also did a user research and testing session with the chosen test participants to gather a more specific user requirements. The user research comprises of three main things, starting by doing an interview, continued with a usability testing, and the test participants are then given a survey for them to fill in. Within the usability testing, the test participants are asked to complete 6 tasks, which are formulated from the context of use. And then from this segment, we will be able to gather information about the personality and the needs of our target users, and also some metrics we can use later in the evaluation. And here are the gathered requirements from all of that process. We gathered from the heuristic evaluation that the main problem is the lack of help and documentation, and also inconsistencies that exists within Proud version 1. Now, while the user research shows that generally the users do not know how to navigate Proud version 1, may be caused by the technical terms that are used, the interaction flow, and a bunch of other reasons which are all noted down and taken into consideration. And from the interviews, we gather information about our target users and we created personas, which are general archetypes about our target users. These are images of fictional characters that represent our target users. These are the 2 personas, each with their own distinctive characteristics. And then the next step is thinking of how can Proud help these personas? So we can help the Wikimedia community member by creating a metric to help them compare topics of interest, because they need a metric that they can easily identify so that they can choose a particular project to focus on. And we can also help the knowledge enthusiast persona to discover dominating or popular items or subtopics in Wikidata. So now we have an understanding on how we can improve Proud so that it helps and benefits the users. To make things more efficient and easy to understand, we did a task analysis. Now, an interesting thing about Proud is that it is a data visualization tool, which makes the tasks the users do are both physical and cognitive in nature. As an example here, the yellow tasks are physical, while white ones are cognitive tasks. And some are a mix of both with physical and cognitive subtasks, as we can see here in the CP task, or the compare page task. The physical tasks are broken down and analyzed to see where it can be improved. And just as an example here, in one of the analyzed physical tasks, we can see tasks which require a lot of steps can be adapted in a way to make it simpler and more efficient for the users. In Proud version 1, it takes a really long and winded steps to complete the subtask, and then the task analysis results in this much simpler and more efficient task. Now that we've established how we can make the application more efficient, now an information architecture blueprint can be made as a skeleton of Proud version 2. Based on the requirements gathered, we can understand what information does the user actually need that are missing from Proud version 1. And here we can map those information to the application. For example, we know that the users need more information about what Proud actually is, so we provide those information in the landing page by mapping them using this blueprint. From that skeleton, then we develop it into a prototype, and the improvements that we do from Proud version 1 to Proud version 2 are done in two kinds. The first one is improvement based on the UI UX elements, which are all listed here, and improvements based on the task analysis and gathered requirements that are specific to the 6 analyzed tasks. Then to help the users by creating a metric, as previously discussed, how we can help the Wikimedia community member, we utilize the Gini coefficient as an attribute imbalance metric. The Gini coefficient is often used as a measure of income inequality. We use it in a way to show the imbalance in property completeness of items in Wikidata. The other changes are done on the interaction flow, the use of words by using simpler words, the charts that are being used, and also a rearranging of the content to make things more compact and simple. We implemented Proud with a RESTful architecture, with the front end using React.js, Chart.js for all of the visualizations, in the back end using Flask. We used live query data, so technical limitation left us with a 10,000 item limit, though it is refreshed live. So when something is changed in Wikidata, the data in Proud changes as well. The chart here explains a little bit about the flow between the front end, the back end, and Wikidata endpoints. So yes, this is just a simple representation of the system. And just as a reference, this is a short demo of how Proud version 1 looked like and navigates. So this is the landing page. And as you can see, it doesn't really have a lot of instructions, but it shows a very simple video of the demo and the landing page. And the terms that are used here are quite technical. So for users who have never used Wikidata before or are pretty new to this application, it can be quite confusing. And if we skip through the video, we can see an example of the dashboard. Here we can see that you need to scroll quite a bit to really see all of the information that are provided in the page. And the way that the information are visualized can be improved. As here, if we want to compare the 3 date of birth, employer, etc., it might be better if we can show it using a bar chart. So that's just an example there. And this is the result of our research, which is Proud version 2. So when you go and create a new dashboard, is what it's called here, while in the previous version it's called a profile. You can go ahead and just select it right on the landing page, and we also provided an onboarding and some examples for the users. And on this newer version, we fit the information all in one page, so when users change something, they can immediately see the effects of the things that they did. So everything is more compact and simple, and you can go ahead and try out this application on proud.it. So a second testing is done to evaluate the results of this Proud version 2. And an evaluation using the measured metrics show that generally, Proud has improved significantly. With an above average perspicuity and an increased success rate and SUS score, it has improved for the better. So the SUS score of 66.75, which is a grade C, shows that it is still under the SUS benchmark, just a little bit, which means that it can still be improved further. To conclude, this research shows that one iteration of UCD has managed to improve Proud for users, hence reaching the goal established earlier. And several adaptations which are done in this research specifically for a knowledge graph application such as Proud is that because it surrounds an abstract concept, we have to do all of these adaptations. A task analysis is done for both physical and cognitive tasks, and the interface improvements are done in those two kinds of aspects. In future work, hopefully we can conduct more iterations of UCD to further improve Proud. And we also are working on to expanding the 10,000 item limit. And more research is currently done. We're analyzing the Gini coefficient as a knowledge imbalance metric. And we are also trying to streamline Proud more into regular activities. And that's all from me. Thank you very much.